Hey everybody, in this example, we are looking at a rational expression and we will be finding the domain of the rational expression. Hopefully everybody here knows that domain is referring to, basically in the simplest of terms, it's referring to what x can be. So we can describe domain in many ways, like we can say, well, x can be all of these things, or we can even describe it, x can be anything except these things. So let's look at this problem. Rational expressions are essentially ratios. A ratio is a proportion, or maybe more familiar as a fraction. When it comes to fractions, there's something that we're not allowed to do, and that is to divide by zero. To divide by zero is big no-no, okay? So we're not allowed to divide by zero. That means we need to avoid any x value that will cause us to have a zero in the denominator, since the denominator of a fraction is the thing you're dividing by, right? Right. Now, fortunately, this denominator was already factored for us. How sweet of them. So since it's already factored, we can apply the zero product property. That's when you have a polynomial. That's what this denominator essentially is. Rational expressions are the quotient of two polynomials. So we're going to look at this polynomial down here. We want to set it equal to zero, or essentially we're setting it not equal to zero. We're saying like, hey, what x value will cause this thing to equal zero? Welcome to algebra, right? So we're going to set it equal to zero and solve, and it's going to give us those naughty x values that we want to exclude from our domain. So it's already factored. So zero product property, zero, set it equal to zero when you have it written as a product. That's a product when it's factored. So I'm going to basically say, well, x plus 2, for now, I'm going to say, well, it's not allowed to equal 0. How do I solve for x? I do algebra. I don't just stare at it with my mind and hope I can do magic. X can't equal -2. And so that's coming from that factor. And now this factor, x plus 4, can't equal 0. Subtract 4 from both sides, and x can't equal -4. So maybe you describe the domain that x is all real numbers except -2 and -4. Or maybe you're a little bit fancy schmancy and you want to write the domain as a wonderful human being and use interval notation. So if I'm saying that x can be everything except -2 and -4, then we're saying it could be everyone else. The way we write that from left to right is the domain goes from -infinity, comma, -4. So as we go from -infinity, like imagine a number line, if you will. Here's -4 somewhere. Here's -2. That's off limits. That's off limits. You're good. You're good. You're good. That way forever, you're good. That way forever, you're good. Who's bad? -4, -2. That is it. So the parenthesis goes against the value that you can't reach. We can't reach infinity because of the fact that infinity is not a value, it's a concept. So -infinity until -4, up against -4, we're going to get as close to as possible, not touch it. Then we put the union symbol to unite to the next interval. This is called interval notation. -4, comma, -2. So it's saying from -4 until -2. These are not ordered pairs. Please don't get confused. Union, we're going to unite it to the next part of the little choo-choo train over here. And now, right after the -2, I'm good really till infinity, right? So I will move my little Frankenstein out of the way. Isn't he a handsome gentleman? Professor Frankenstein. -2 until infinity. Sorry, I'm really bad at drawing infinity as like a regular sideways 8. It always ends up being a regular 8 because my hand just wants it to stand up, I guess. But there you go. There's your domain of this rational expression. All right. So if you get it, got it, good. Give a thumbs up to mark the spot. Like say, hey, I watched this already, registered, understand. I think Frankenstein's a wonderful, dapper young man. If not, thumbs down if you're confused, but this way you know you already watched it, addressed it. Leave me a question, comment, concern in the comment section, and I will try my best to respond. I'm gonna make a put this on a playlist, whether it's on one already or I'm starting a new one, or I'll double it up, but there'll be a playlist on the screen and all the videos matching this set will be on that playlist. That's it for now. Adios.